So first, I will introduce encoder axis addition and configuration. Here, in our software, on the right side, we can see project management, and we can right-click this motion control axis to add axis. And with this interface, we can see for now, 6V support these three type axes: bus servo axis, local post axis, and local encoder axis. So if you want to use the high-speed counter, we need to add a local encoder axis, the third one. And after add encoder axis, we need to configure the unit setting, because in function block we use the user unit, not post unit. So we need to set this for our function block. With this default setting, it means when our 6V receive 10,000 pulse, then the function block will record 1 unit input. So this is the relationship. So if we change the setting to this one, it means every time when 6V receive 40 pulse, then our function block will record 2 units. So it means 1 unit is 20 pulse. And the next, after setting the unit conversation setting, we need to set some parameters about our high-speed counter. First is the rotate mode. For now, we have two modes: linear mode and rotation mode. For linear mode, it means the counting value will increase or decrease with according to the account direction. And for this mode, we could set 2 limits. One is forward limit, and another one is a negative limit. When the counting value, for example, if now we are count up, and when the counting value is beyond this forward limit value, then our 6C will report an error, and then the counting value will stop at the limit value. It will it wants to continue to count up. At this time, if we input a reverse pulse, the counting value will begin to reduce, and then the error will disappear. This is in the linear mode. And the second is rotation mode. For this rotation mode, we can set 1 cycle of the rotation. For example, the default setting is 360. It means when the counting value, for example, from 0, 1, 2, 3, and achieve 360, and if we continue to count up, the counting value will change to 0, and then go ahead, continue, and from 0 to 1, 2, 3, 4 to 360, and change to 0 again. So this is rotation mode. And last, we need to set the function setting. Some function here. For example, first is torch pop selection. We could set it as X3 or X7. This function is used to record the counting value, or you can say it is encoder position. I will introduce this function in details later. And the second is preset setting. We could use X2 or X6. This function is used to set the counting value. For example, we can set the preset setting value as 1000, and when we trigger this X2 or X6, the counting value will be set to our setting value 1000 directly. And the last one is output terminal setting. It means we can set a compare value, and when the counting value is same with our comparison value, our 6V will output one signal according to our setting output terminal. And here we can set the output type. We can set it as unit. It means Y0 will output for 1 unit limit, 1 unit. Also, we could set it as a time unit. For example, we can set it as 1000 ms. So Y0 will output 1000 ms after the counting value is same with our comparison value. Okay, so this is the function setting of our high-speed counter. Here, do you have any questions about the axis addition and the configuration? Okay, if no questions, I will continue to introduce function block, high-speed function block. Okay. Okay, here for this first function block, HC counter. This function block is used to enable our high-speed counter. And this function block only have 3 inputs: enable, invert, and axis. For axis, we need to set the same axis ID with the counting axis. And this invert is used to change the counting direction. And the output side, we can see the position. This is the counting value in user unit, and also direction and velocity. It depends on the input frequency. Okay. And the second function block is this one, preset. This function block is used for setting counting value. We could see here we have 4 inputs. This trigger edge. This means we could use hardware to trigger this preset, or we could use direction use enable to trigger it. If we set this one as 1, then we will use hardware to do the preset action. And if you set it as 0, then when we enable this function block, the counting value will be set as this position directly. And the next function block is this one, compare and output. This function block, we have 5 inputs: enable axis and this position. This position is our comparison position. It means when the counting value here, this output of this HC counter, this position, when this position is same with this compare position, then our high-speed compare function block will be executed and to output the hardware with setting, and also to execute the interloop program. So for this output enable, if we set it as true, then our setting output terminal, for example Y0, will be set on. And for this interloop map, we could add a interloop program name here directly. If we didn't add anything here, it's also okay. So this is the this three function block, how this three function block works. And the next, we have this function block, HC torch probe. This function block is used to record the position. Here we could see in input side we have 5 parameters. This trigger edge we have three settings. 1, 2, 3. 1 means rising edge trigger, and 2 means falling edge trigger, and 3 means double edge trigger. And on the output side, we could see we have a positive position and a negative position. So here, for example, we use double edge trigger, and we use X2 as our touch probe. So when we get a rising edge of X2, the counting value will be recorded in this positive position. And when we get when we get falling edge signal of X2, the position will be recorded to this output. So this tool is used to record the position of encoder. And for this trigger mode, we have 2 modes, 0 and 1. 0 means our torch probe will only record 1 time. And after record 1 time, it will be changed to down status. So this function block will not take effect anymore. And for 1, if we set this trigger mode as 1, it means continue recording. So when we get X2 and X2 signal, this function block will not be changed to down status. It will continue to record the position. Okay, so this is the difference about trigger mode. Here we have another tool function block. We call it area composition. This function block is, and also this inquiry space comparison. This two function block is similar to this compare function block. For this one, it is used to compare the area. For example, we could set a area as 0 and 10, 20, and 40. And for the length, area length, we set it 1, 2, 3, 4. Set it as 4. So when we execute this function block, when the counting value when the position is become 0, our Y terminal will output 1 times, and this interloop function will be executed 1 time. And when the position achieve 10, this Y terminal will be output one time again, and this interloop function will be executed again. And when the position achieve this 20, also for this 30, every this hardware will output one time, and this interloop function block will be interloop function. Sorry, and this interloop program will be executed one time. This is different because for this for this function block we will compare it many times. It depends on the length of our setting area. But for this compare, we only compare it one time. And for this comparison, we call it as step compare. It means we can set one start position and one end position. Here I set it as 0 to 100. And also we can set the steps. Here I set the step as 20. So we will get 0, 20, 40, 60, and 80 between 0 and 100. So it means every time when the counting position achieves 0, 20, 40, 60, 80, and 100, our hardware will be output one time, and the interloop program will be executed one time. If within the same range, if we set the step as 1, it means when the counting value achieves 0, 1, 2, 3, 4, and until 100. Every time when the counting value achieves this value, our hardware will be output one time, and the interloop program will be executed one time. So this tool is also used for comparison. Okay. So here, do you have any questions about this high-speed function block? For now, we have 6 HC function block in 6V. Okay, so now I will continue. I will use a program to show how this works. It will be more clear, I think. So our last part, demo program display. And for this demo, I connect our 5V to 6V. 5V10 connect to 6V X0 and Y2 X1 and Y1 X1 Y2 X2 and Y3 connect to X3. Let's open the program. This is 5V program. This is 6V program. Let's check the axis setting first. We could see for this axis 0, I set it as local encoder axis. And for the unit, I use default setting. So when I use this, when I use 5V, send 10,000 pulse to 6V, we will get position 1 in this HC counter function block. And for the parameter setting, here I use linear mode and set the forward limit and the negative limit. For the prop setting, I use X3. So we could see here in 5V program, I use this Y3. This Y3 is connect to X3 of 6V. So when I set this M4, it means we will record one time the position. And for the counting mode, I use pulse and direction. X0, wait. So this one. So Y0 is the pulse output and the Y1 is the direction output. And for the preset setting, I use X2. And in 5V program, this line, when I set on M3, the counting value will be set to the preset setting value. And the last, for the compare output, I use Y0 and use the output time as 1000 ms. Okay. So here we first enable our counter. And the 5V, here, we send pulse with this 10, let me check, 100,000. Here, we could see the counting value is reduced now. If we change the counting here, if we change the counting direction, we could see it is increasing now. This is the speed. And also we could change the output pulse to 10,000. Then we could see the speed will change to 1. Okay. And the next, this HC preset, this function block. I set the trigger edge as 1, so it means I will use hardware to preset the setting value, preset the counting value. And the position is 1000 here. So now M3. So now if I set on M3 with output Y2, the counting value will be set as 1000. Okay, we can see it is changed to 1000. And this function block is status is done now. And the next one is this HC torch probe. Here I use double edge trigger and use continue record mode. So in 5V, we could use this Y3 to record the position. Sorry here. So we could see when we get the rising edge of this X3, we will get one position in this positive position. And when we get a falling edge of X3, we will get another position and stop it in a negative position. And this is continue record mode, so we can record many times. Every time when X3 turn on or turn off. Okay. And the last is this HC compare, this function block. Here I set the compare position as 1000 directly. Okay. And so now when the counting value, this counting value is achieve this 1000, Y0 will output for 1 second, and the M100 will be set on because in this interloop function, here set on M100. So when this interloop when this interloop program be executed, M100 will turn on. And now we could use this preset, this function block, to set the counting value to 1000 and achieve this compare function block. Let's try it. M1 set 1 and okay, because here we use hardware trigger, so we need to output Y2 to preset the value. Okay. Y2. You could see here Y0 is output for 1 second, and the M100 is set on now. Okay. And so this is how this HC function block works. For this two, is same. So I didn't display this, didn't show this two. If you have 6C on your hands, you could test this function block yourself. Okay, so for now, do you have any questions about local encoder axis of 6V? How to add this axis? And how this unit conversation works, and how these parameters works? Do you have any questions about this? And also for the usage of this function block. Oh, and for the firmware of 6V, we need this version firmware. We want to use local encoder axis when of our PLC firmware should be above this V1.859. And for my PLC, this version is the newest one. Okay, so if no questions, our today's training will be finished. For firmware updates, we could remote to help you to update the firmware. Okay, so do you have any other questions? If no, we will finish today's training after 2 minutes. I will also upload this meeting video to our YouTube. And if you need, you could check the video on YouTube also. Okay, thanks for your attending. See you next time. Goodbye.